Hey guys, welcome back. Today we will be solving problem of grid. Yeah, DP on grids. The topic is DP on grids. And the problem which we will be solving, let's try to understand the problem, what the problem says. There is a robot on an M cross N grid, initially located at the top left corner. Robot tries to move to the bottom right corner. Bottom right corner. The robot can move either down or right at any point of time. Down or right. Got it. Given the two integers m and n, there is two integers m and n. Okay. Return the number of possible unique paths that the robot can take to reach the bottom right corner. Like in this position, it want to reach, and you have to get the robot to that position, and you can move either to the down or to the left. Okay, and you are given m and n, like number of rows and number of columns. Okay, does this seem easy? Yeah, it is pretty simple problem. You can solve it. So if you ask me, how I'm gonna solve it, so I'm gonna return solve -1 to n minus 1. So we are starting from the end and we are moving to the 0, 0. If we reach to that position, we're gonna add 1, like the position is what this position. So we're gonna like 1 is included. So you have to include that position. Okay. And you have to add both the position. You can up or you can go say see in that position, if you're from top to here, then that would be like down or left. If you are from here n-1 and you move to the 0 0, then it would be like up and left. That is the positions. Got it? So now in solve, let's say int I and int j, two indices which is pointing now it is pointing to the end, n-1 m-1 n-1 n-1. What we are going to see, first you need to know what we are going to do, why we are going to do. So we are going to solve it by recursion. Whether you can find other ways, no, obviously no, can't find any other ways to solve this problem. Okay. Yeah, so yeah, so what I'm telling you that we are solving it by recursion. The other way you can't find, like you can't to go to this direction. So yeah, now in recursion, what we have to write, we have to choose all the paths, and yeah, so you need to write the count number of ways to count. You have to go in all the directions possible direction, all possible direction. When you see the term called as all possible, like counts, just add it and get it. Obviously we are going to do it by recursion, and in recursion you have to write base case. If let's say I is 0 and j is equal to 0, we have to include it. If let's say, obviously, if I'm going up I less than 0, there is also possibility of j less than 0. If return 0, because not include, you should not include it. You're including it, so you return 1. You're not including it, return 0. Now we have to calculate up. If let me let us think what will be the up. Up, up, column is same, but row is what? Oh my god, a minus 1 and int lets it down. We like solve, obviously. Sorry, why down? No, down, not left, left. So column minus 1 and row is same. Yeah, and return up plus left. Yeah, so this is the way to count number of ways count. So it would work the test case, but it will not give us the time limit exit. Why? Because here constant is given to 100 and we are getting like 2 to the power n. You can see 2 to the power m into n, obviously. Like two choices there, whether we can go up or we can go left. So there is two choices in every, like every, what do you call this, indices or point or boxes has 2 to the power m into n choices. So that's why you have to just do this, do the dp solving by dp. So can make vector, can make something like that also, but let's try to solve this like this. Or no, I don't want to. So vector of vector in vector of vector int pp, let's say m, then we can get m minus 1 and vector int nn minus 1. Okay, so we have made up dp, pass it. What do you do? Pretty simple, pretty simple. If dp of ij, yeah, not equals to minus 1, return dp of I and j, and for returning you have to just dp of I j is equal to, for returning we have to do this, and also one thing, to pass it here and here, and you have to do one thing, first pass it by reference. So it is gonna work, it is gonna work. There is no, yeah, I told you that it is gonna work. There is no, that you can now tabulate it because there is a space for recursion also, which is path length, path of length, that is m and m plus. There's a, or it will be like say m plus n, let's say. Yeah. So now what do you wanna do? We are gonna also that there is a vector, so m into n, m into n plus. So you're gonna space complexity can be reduced by the use of recursion. It was tabulation. However, so what do you wanna do? Remove this part. We don't need this. Actually, we don't. Remove it and also remove this thing. So we're gonna do int, let's say dp of m and n. Yeah, for int I0 I less than n plus plus nested loop j0 j less than n j plus plus. Yeah, so we have made a two loops, and if let's say I is 0 and then j is 0, return 1. And there is one thing that if I is less than 0 and all that thing would be like, it would be like, yeah, 0 obviously. So else I, let's say, int up, it would be 0, and left would be like, let's say, 0. And if I is greater than 0, yeah, yeah, so up would be like, mm, solve uh -1 I, okay, so sorry, like dp of -1, yeah, I -1, yeah, so okay, if 0 down, left, my brain is paining, like it's like yeah, so a -1, yeah, yeah, so at last what you have to do, we have to just return up plus left. Oh no, yeah. Sorry. uh so it would be like I think I outside. Wow, yeah, so mm, where should I pretty different problem? Ah, got it, got it. No, it would not be. Sorry. TP of I, J will be up plus left. Good. You see, 9 point something, na? It will be reduced. See how much it reduced. So hopefully you have understood this problem. I'm gonna do something. Next problem. This is done now. Let's try to solve this problem. Okay, so this problem has some blockage or something. It's also pretty simple though. Okay, yeah, I can solve this. In this problem, what we are gonna do, we are see there is a m cross n integer I create the robot. Okay, okay. Hmm. Okay. Okay. So you have to reach here. It is zero, no problem. It is one. There is a problem. There is a problem. You have to count number of ways. Be like one only. So this is similar to the previous problem, but there is something. Just copy and paste this thing. There is something which I'm gonna tell you. So I need m obviously, otherwise it is not possible. M would be like obstacle grid. What the dot size and int n would be like okay, 0 dot size. Okay, so this is the stuff. Pretty simple. And now what you are gonna do? Mm, yeah. So so what is happening here? If it is one, if grid of this is one, then we should not count that part. Should turn zero. Yeah. Okay. Yeah. Yeah. So to count if obstacle count a j is one, j zero, count it. Then else hopefully it will work. See, I told you. I told you this is also done. So will I do next problem also? Let's do uh I'm like Okay, minimum path sum. So I have to get the minimum path. Yeah, I can solve this pretty simply. But my brain is so pain. Wait, let me take some rest and